stuff you have to remember. So what I do, instead of memorizing, which you can memorize if you want, is I just draw the picture. And what appears to be true generally is true. So we did parallelograms yesterday. That's all we did. Today we are going to add in a rhombus, a square, and a rectangle. And because they are parallelograms, they have all of these properties. Well, what's one of the properties? Opposites, this is a definition. Opposite sides, both pairs, are parallel. Yeah, but you're going to miss the lesson. Okay? Garrison. You have your iPad open. If you don't have an iPad, you certainly can borrow some paper from me, and you can write it down. You learn by writing. So when I do the study guide, I'll leave it open-ended for you. Okay, so you should be writing down both pairs of opposite sides are parallel. What else is true about parallelograms? Now you know lots about parallelograms. Forget that you're in geometry class. You've learned this since you were in 4th grade. So these are parallel. It has 4 sides. Doesn't help me much, though. What's true about opposite sides? Zach? Opposite sides are congruent. So these are congruent and these are congruent. You already know that. I know you know that. Now, this is just for a parallelogram. I don't know anything about right angles or anything like that. What about the opposite angles? I want to know about the angles, the diagonals, and the sides. So I've got parallel lines. I've got congruent sides. What about this angle? Now, if it looks congruent and you have a decent picture, it probably is. And that angle. What do you think? Yeah, opposite angles are congruent. So you have to remember all these things. But if I just draw the picture, that's why I'm going through this exercise right now. If I just draw the picture, I can figure it out on the test. Yeah, actually it does, because what appears to be true generally is true. What about consecutive angles? What about this angle here, 1, and angle 2? And this is angle 1. They're not congruent. One's obtuse, one's acute. They're supplementary. Angle 1, the measure of angle 1 plus the measure of angle 2 has to add up to 180. Generally speaking, if you think back of everything we've talked about so far this year, things are either congruent or they're supplementary, or maybe complementary. But 180, you've seen a lot. Oh, let's draw the diagonals, because the diagonals have a special property too. There's one diagonal, and there's the other one. Are they congruent? Well, let's pull that out. Now let's take this one out and, come on, I want to rotate this thing. Let's try rotating that one. No, that doesn't rotate. It just flips, but we can flip it. I mean, if you look at that, do they look congruent? No. So let's flip it back and put them back in there. But they do some other things. They're not congruent. Makes a midpoint where they intersect is a midpoint. Okay, you guys? So if that's a midpoint, what's true about this segment and this segment? And this one and this one. And if two segments intersect in a midpoint, what do they do to each other? They bisect. Now, you know what bisect means. Cut into 2 equal parts. Okay. So when you know you have a parallelogram, you know you have all that information so that you can set up equations and solve, find missing sides, find missing angles. Do the diagonals bisect the angles? Oh, sorry. Do the diagonals bisect the angles? Is this angle here congruent to that angle there? Look how long this is. It's pretty short. And then look at this. If I wanted to check it with a compass, I could. No, the diagonals do not bisect the angles. I'm not even going to write it down because it doesn't do it. Okay. Well, when I talk about a rhombus, a rectangle, and a square, they are all parallelograms. So they have all of these properties, but they have some additional ones. What is a rhombus? Actually, it is a kite, so it has all the properties of a kite, and you've probably forgotten them. But I'm going to give you a worksheet that has you write them down. But I just draw a picture. It's not regular. Regular means what? All the sides are equal and all the angles are equal. This is obtuse. This one is acute, so they're not equal. But it's what? What's true about all the sides? All sides are equal. That's why it's a kite. Because the definition of a kite is two pairs, okay guys, of consecutive sides congruent. So this pair and this pair, well, it turns out they're all congruent. So it's a special case of a kite. So it picks up all the properties of a kite. Yeah, leave my laser be. Because there just is. Comes that way. Okay, what about opposite angles here? Opposite angles are congruent. Well, it's a parallelogram. It has to be, right? So what else do I want to know? How about the diagonals? Should we put them in? Now, if I draw a nice picture, which it wasn't that nice. There, that's better. I'll be able to make an assumption here. They're perpendicular to each other. If I draw a nice picture, but you know what? We knew that about a kite. Think about what a kite looks like. Here's a kite. If we draw the diagonals in a kite, they're perpendicular. Now, okay, guys? A kite, one diagonal bisects the other. But in a rhombus, this is perpendicular. All of these are right angles. What's true about this segment here and this one? And this one and this one? They're equal. So the diagonals are perpendicular bisectors of each other. Not true in a kite. They're perpendicular. One bisects one of them. And I have to draw the picture and figure out which one's which. That's the easiest way to do it. So the diagonals are perpendicular bisectors of each other. Good. A little bit more. No, a little bit more too. What about the angles? This angle here equals this one. These triangles are equal, if you think about it. So what's true about 1 and 2? Are they different or are they equal? Look at the picture.
1 and 2, they're equal.
Yes, angle 1 is congruent to angle 2. How about 3 and 4?
Equal.
Guess what? What about 1, 2, 3, and 4?
All congruent.
They're all equal. Okay, what about 5, 6, 7, and 8? They're all congruent too. Angle 5 is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. So what do the diagonals do to the opposite angles? They bisect the angles. Diagonals. Question. I'm sorry, what? bisect the angles. So I get a lot of information, but you know what? Look at the picture. If I draw a nice picture, I know what's happening. Perpendicular bisectors of each other. So that means that this segment here is bisected, these two are equal, and that's perpendicular. And not only that, this other diagonal is bisected and perpendicular to each other. Oh yeah. So you should have it written down. Yes, you know I do save it, and I do put it up on Schoology. So a rhombus is a special case of a kite. Is a kite necessarily a rhombus? No. That's where it's going to be hard. A rectangle has to be a parallelogram. Does a parallelogram have to be a rectangle? No. That's the problem. So you have to read carefully. Otherwise, you might answer the question incorrectly, but knowing the right answer. Are we ready to do the rectangles? What's true about rectangles? The diagonals bisect the angles, the vertex angles. I don't want to call them vertex because yeah, they're all vertex, I guess, because they're all equal. Well, what's true about a rectangle? It has all the properties of a parallelogram, but it has more. What's true about these angles?
They're all 90.
Okay, so it's equiangular. They're all 90. We know that, don't we?
And then when you bisect the angles.
Well, I'm not going to bisect angles. Draw the picture.
They all make 45.
Let's try. No, they don't. Let's draw the diagonals. Take a rectangle. And I may redo my square because it's not really square, I don't think. Yeah, I was going to say. So let's draw the diagonals. Is that bisecting this corner angle? Look at the picture. No. This second angle, lower angle, is bigger than the other one. Well, if you draw a square, it will. But what's true about my diagonals?
Make a midpoint.
I get a midpoint, but what else is true about the diagonals? What's true about their lengths? Okay, all the diagonals are congruent. Sorry. The diagonals are congruent. And we knew that that's a midpoint because it's a parallelogram. Diagonals in a parallelogram always bisect each other. Make flashcards so you know that, whatever it takes for you to remember. So yeah, these are going to be congruent. Well, they're all congruent, aren't they? Are they perpendicular? No. They might be, but there's no guarantee. Not necessarily perpendicular. Doesn't bisect the angles. I think that's all I can think about with the square. Can you think of anything? A square, rectangle. Well, a square, you know what? I'm going to put a new square in here because I actually want a square, and I don't think mine was a square. Okay. Whoops, a little extra square there. Now, what is a square? All sides are equal, so it's equilateral. There's a lot of vocabulary here. It's equiangular. Well, we'll draw them in a second. What's the word that says equilateral and equiangular?
Regular.
It's regular. Good. So guess what? It's equilateral, it's equiangular, so it is both a rhombus and a rectangle. And it picks up all the properties of both of those. So what's true about all my angles? They're all equal. How big do they measure? They're all 90, right? Yeah. Okay, let's draw a diagonal in here. And I should have a real square this time. And because it's a rhombus, which means it's also a kite, what's got to be true about my diagonals?
Angle or
They must be perpendicular bisectors of each other. Okay, so diagonals, can I just abbreviate it? Diagonals are perpendicular bisectors of each other. So and what else? The diagonals are congruent. So guess what's true about all those little segments? They're all congruent. And if these are congruent, then these angles here have to be congruent. And if this is 90, how big does this angle have to be? 45. Remember, they have to add up to 180. Well, and if this was 90, this is 45. What does this do to my opposite angles? The diagonals bisect the opposite angles. This is the most particular one you can get. Diagonals bisect the opposite angles. So there's lots and lots of congruence here. We're going to be dealing a lot with 45, 45, 90 triangles in the future. Not for a while, though. Is that okay? Square root of 43. Can't simplify. Yes. I'm sorry, what? It means the diagonals are the same because it's a rectangle. Diagonals are congruent in a rectangle. What's true about all these little triangles also? They're all the same. So the diagonals divide your square into 4 congruent triangles. Yes. It's an isosceles right triangle. Okay? We start with parallelograms. We know this. I think the one that may be hard for you to remember is this one and maybe that one, about the opposite angles being congruent, consecutive angles being supplementary. I don't know. And then rhombus, you pick up more properties. Rectangle, you pick up different properties. In a rhombus, the diagonals are perpendicular. In a rectangle, they're not. But if I combine a rhombus and a rectangle, I get a square, and then I get everything, which is kind of nice, kind of. Okay, well, that's what lesson 8 does. It's the reason I wanted you to do this first. Now we're going to go through the lesson that was already written for us, and it'll go fast. What do I do when I don't know? I draw a picture. I look at it and say, well, what does it appear to be true? They look to be right angles, don't they? If you draw a nice picture. So I'm going to bring up my other lesson 8. I have mine done. You may not have yours up yet. I got to find it. Oh, let's see. It's here someplace. Where is it? Oh. You know what? I don't know if I saved that. So I'm going to do this. So bring up lesson 8. Okay, do you have it? Okay, Zach? Zach, do you have your iPad? Oh, well, you can use a piece of paper. I got lots of paper. Getting low. Yeah.
I wish my handwriting was super neat and then I said,
It gets better with practice. We'll make it bigger. Okay. This is the goal. We want to know about rhombuses, rectangles, and squares, and we want to know about their angle measurements. We've already done it. So this should go actually fast. Okay, I've already talked about this. Any property that's true for a parallelogram is true for a rhombus, a rectangle, and a square because they are parallelograms. Parallelograms need not be squares. That's what makes it hard. It only goes one direction. Okay, I thought this was kind of weird. I'd never seen this before, this double-edged straight edge conjecture. But let me do this a little differently. I didn't like that ruler. What I'm going to do is draw a couple lines, parallel lines. Now, what I'm going to do is group that. I want that distance to be the same. I'm going to draw another pair. So I'm going to group it, and then I'm going to clone that. And I'm going to rotate that. When I take parallel lines and I intersect them with another set of parallel lines that are exactly the same distance apart, I get, that's right, I get this shape, which is a rhombus. Now, I don't know how useful that is, but that's what you get. Okay? That's this conjecture. I'll look at the test and see if it's really important. I don't think it is. I've never seen it before. Now, you could get a square. The reason why I didn't like this is because you will get a square because these are perpendicular to each other. But you don't have to. Yes, again. No, only on a square. Okay, ready? So then, okay, let's quickly go through this. Okay, Zach? A rhombus is an equilateral parallelogram. We already know about this. What's true about the diagonals of a rhombus? What do they do? What do they do? Look at the picture. They're perpendicular bisect to each other. And yes, so those of you who don't have your iPads or whatever, I will save this and you can print it out. Okay, what's true about the diagonals of a rhombus? Look at the pictures. They bisect the angles. Now, you could test yourself with this. Now, what I'm going to do, though, on your study guide, is have you list all the properties. I'm not going to give you these fill in the blanks. List them. Can you say them? All the properties of a parallelogram are true for a rhombus. Okay, ready? Okay. And actually, well, you'll see in one of the slides, it'll be totally complete.
What was that one? Perpendicular bisector and what was the other one?
Bisect the angles. Yes, the diagonals of rhombus, perpendicular bisectors of each other. And the diagonals bisect the angles. We already know the diagonals bisect each other. Okay, ready? What about in a rectangle? Look at the picture. The diagonals are what? Cole? Look at the picture.
Diagonals are
Congruent. And what do they all do to each other? They bisect each other. I already knew that because it's a parallelogram and diagonals bisect each other in a parallelogram. More than that, what's true about the angles at each vertex? The vertex angles are all 90 degrees. Do they? Look at the picture. Look at this angle here versus this angle there. This is a lot smaller than the other one. Can you see that? No, they don't. They will if my rectangle is a square. That's what makes this tricky. And I have to think hard, too. It's not like I have memorized these. I have to think. Okay, ready? Properties of a square. That's got basically everything. The diagonals of a square, are they congruent?
yes.
Okay, so they're congruent. What else? Oh, what's true about the angle formed between them? They are perpendicular. And they bisect each other. You could have said perpendicular bisector. And what do they do to the angles? Look at the picture. Yeah, these two angles are equal, so they bisect the angles. Good. So you get all the properties of a parallelogram. to the square. Okay, ready? Okay, homework is lesson 8. I'll get that for you. The review is being printed. If you want to start it, you can. It's online in Schoology. Now, I wish they had done the colors a little differently. This part here, all these properties of a parallelogram, that's this. Okay, Cole? When I have a parallelogram, I know my opposite sides are parallel congruent. That's easy. Opposite angles are congruent. Consecutive angles add to 180, and the diagonals bisect each other. That's the one you can't forget. Well, a rhombus and a rectangle all have all those properties. And the only difference is a rhombus is equilateral, the diagonals are perpendicular, and the diagonals bisect the angles. Okay, a rhombus is also a kite, which is not a parallelogram, but has all the properties of a kite. So if you go back to that lesson, you can find those. A rectangle is equiangular, they're all 90 degrees, and the diagonals are congruent. This is just summarizing everything we've done. So everybody has all of this orange. They're all the same because they're all parallelograms, but these are the special conditions that you get with a rhombus, rectangle, or a square, because a square is both a rhombus and a rectangle. You get them all. So I'm going to have the orange, and I'm going to have all the blue here. And the blue is this. This is the blue. And that's a square. Just draw a square. You'll figure it out. But it's got to look like a square. Okay, Sydney's? I get two. Sydney's. Okay, you ready to try some problems? Yeah. You don't get your notes. Look at the picture. What do you think is true about the diagonals? They're equal. And I know it's a parallelogram, so I know they bisect each other. So how big is RG? Now, please put in the units. I don't know if we're going to be picky about units on this test. And because it was divided in half, and these are equal, this length is 30, so the other one is also 30 centimeters. That wasn't too bad, was it? And sometimes there's more than one way to do these problems. Well, I have a rhombus. What do I know about RM and RH? The rhombus. Look at the picture. They are equal. So 2x minus 5, this is what I want to see, equals 23. I want to see that. Okay? I want to see the equation. I don't care about the algebra. That's not my goal here. My goal here is to make sure that you knew what to set equal. And then, if you make a mistake after that, then I'll have to figure out what that mistake is. But the geometry is 2x is equal to 28, so x equals 14. Now, if they were not nice numbers, you'd have to actually write that equation out. But we give you nice numbers because we don't want to be stuck on things that are ugly numbers. But in the real world, the numbers are not nice. There's 14. So what's MH? Well, how big is this point here to H? It's x plus 6, so it's what? 20. These diagonals are bisected, so that's 20. How big is MH? 40. If you know your properties, then this should be easy. If you don't know your properties, it's going to be a problem. Okay, ready? And that's the last example, I believe. There's only 3.
There's one more, but yeah.
No, that's just homework. Now remember, this is a rhombus. So these sides are parallel. And when I give you the study guide, I'm going to remind you about the triangle conjecture. The sum of the angles of a triangle is 180, because we have the sum of the interior angles anyway. And I'm going to remind you about parallel lines. C is one of the easiest ones to get. It's 27. Do you remember what those were called? No, alternate interior. So that was C. That's 27. And there's a variety of ways to get other things here. Opposite angles are congruent. Oh, I know what B is. That's also an easy one. Look at the picture. They look like they are perpendicular. In a rhombus, they are perpendicular bisectors of each other. Am I right? Go back and check your properties. So that's 90. So this is 90. So I could find A. Well, you know what? It's easier than that. But use a calculator if you want. I'm going to subtract 90 from both sides. So that A plus 27 has to add up to 90. Another word for that is complementary. What number do you add to 27 to get 90? 63. And A and D are the same. Now, there's more than one way to get this, by the way, because that's bisected. Or I could do this. No matter how I do it, I got to get the same answer because all those properties hold. So A and D are congruent, but I could have gotten D this way and said this is bisected. I could have made it easier. So D is 63. Once I knew D was 63, I knew A was 63. It doesn't matter how you do it. I'm not grading you on that. I'm grading on can you find them. That's all. Okay? That's it. Now, you may have some questions on, oh, there it is. You may have some questions on lesson 7, in particular number 7, with the octagon and the square. Did you? This is the blue. It was, sorry, they're both blue. This is the blue one from yesterday. I can go over it if you need me to.
This is honor geometry.
Yeah, it's okay. We're doing the same thing. Now, the first side is not easy. You may think it's easy when you're honest for today. There's not that much difference. Oh. I see. Okay, who else do we have here? And remember, I always put all these up online anyway. So if you are absent, you always have them. Do I need to do number 7 from yesterday or not? It's okay if I do. You are for today. Are there any questions on this? This was not a long assignment. I'll tell you, during the review, if you haven't finished the first review, I would. If I've seen the test, I would. And then, well, there's a lot of stuff in this chapter. Really, there is. Well, that was because of the constructions. How about this? By the way, this pattern in number 7 is called a tessellation. So maybe you want to be a designer, floor designer. Tessellation.
I've seen that.
Yeah, this is just patterns and you put them together.
This one would be blue and that one would be white.
Yeah.
Seen that.
Is it A135?
Yes, it is.
Okay, I did it right.
Did you guys all get number 7? Let's look at it. For those of you who want to look at it. Those of you who know how to do it, great. Okay. That's a pattern that we repeat. Current. Turn around. Okay. This is a square. Obviously, this is 90 degrees. Now, there are 2 ways. Shh, you guys, Cole. There are 2 ways to get this angle. There's the easy way and there's the hard way. I think the easy way is to work with the exterior angle. Okay, TJ. This is a regular polygon, which means all of these angles are congruent.
135.
How did you get that?
N minus 2 times 180 divided by 8.
Okay, so we found the sum of the interior angles So that was equal to 8 minus 2 times 180. That's one way to find the sum of the interior angles. Another way is to say that there are 8 of those angles, and they're all equal. So 8a equals 6 times 180. But there's actually an easier way. This is the exterior angles. Do you remember what the sum of the exterior angles is? I don't care what kind of shape it is. It's 360. Well, I have 8 of these exterior angles, and they have to add up to 360. So I'm going to divide by 8, and I've done the problem, so I know it's 45. Is that okay? Those of you who did the first way, it's harder. This way's easier, actually. So if this is 45 degrees, how do I find angle A? A plus E has to equal what? 180. What do you have to add to 45 to get 180? 135. Now, after you've done enough of these regular octagons, you will know it's 135 degrees. You'll just know it. Because there's only so many figures we can do. Through a dodecagon is all we've really done. We've done some other ones. Are there some other questions on yesterday's blue sheet? Now, that back side of today's blue sheet is tricky. So I'm not sure that I really like it because we didn't do problems like 14, 15, and 16. How do you know if you have a parallelogram? Sides have to be parallel, so you're going to have to use slope. Yes, slope. Or you could show both pairs of opposite sides are congruent by using Pythagorean's theorem. So I'm not crazy about those 3 problems. The other ones are okay. And the first one is hard. Number 1, the diagonals of a parallelogram, are they congruent? TJ, are the diagonals of a parallelogram congruent? They are? Always? Always? No. Draw a picture. Here, I'll make it even more slanted. And draw the diagonals. This one and this one. The red one clearly looks longer to me, so no. Okay, Cole? So it's false. So draw a picture or explain why it's false. This is the reason for number 1. It's false. That's why you need to check your answers. 2, consecutive angles of a rectangle are congruent and supplementary. So you know what I'm going to do? I'm going to draw a rectangle, and I know what that looks like. Are the consecutive angles, are those guys congruent? Oh, yeah. Yeah. And because they're both 90, are they supplementary? Yes. So this is true. You think true false is easy. It's not so easy. How about the diagonals of a rectangle? They bisect each other. Why?
Because they do bisect each other.
They bisect each other because it's a parallelogram, and the diagonals in a parallelogram bisect each other. This is how I draw a parallelogram.
Wait, so why is it diagonals?
Diagonals in a parallelogram bisect each other. It's one of our properties. This is the homework, but you can start on the review so you can ask me questions tomorrow. Remember, I'll be here in the morning. You guys don't come in.
I came in once. Third eye.
The diagonals bisect each other. They don't bisect the angles.
Wait, so it's the review the homework for tomorrow?
It's due Friday, your test day.
So that's due Friday.
This is due for tomorrow, and the review is due Friday, and you have a little quiz tomorrow if I get it arranged. And you will need an iPad. Well, I suppose I can print some out. And if you haven't finished those white worksheets from Monday, you should, because that will help you study for the test. You have to know the properties. If you want to make yourself some flashcards, then do it. Yes? Let's take a rectangle. Let's take a skinny one, and let's draw the diagonal. Is this angle the same as that angle? So they don't bisect the angles. That's the problem. Draw a good, now don't draw a rectangle that looks like a square because then the answer is going to be true. So that's a little bit of a problem. So you should be starting to review tonight. Go back, look at all the notes I did. They're all there.